We're still on trigonometry. Okay, we'll be looking at the addition formulae. Okay, we want to look at let's see sine a plus b. Okay, which will be sine a cos b plus cos a sine b. So when you are talking of sine a plus b, it's going to be alternating between a and b. Sine a cos b, and when you stop here, cos b, it will take the other angle, cos a and sine b. Okay. Um, then sine a minus b, it's the same thing. Sine a cos b, then minus cos a sine b. Then let's see cos a minus, let's start with plus b. For the case of cos, it will be cos cos a cos b, and then the sign you have here, the plus sign you have here, we change, we will reverse, and then you have sine a sine b. Okay, then the next one is cos a minus b. Cos a minus b will be the same thing also, but this sign will reverse, and that will be cos a cos b, then plus sine a sine b. Okay, so that's that on that sine and cos of two different angles. So let's now see the main one, the tan a plus b. How do we get tan a plus b? Okay, then we must know that tan is sine over cos. So, and the angle we have here is what? A plus b over a plus b. So that's that on tan. Then can we do this one, sine a plus b, which will be sine a cos b, then plus cos a sine b. Okay, then this one will be cos a cos b, then this plus to change, minus sine a sine b. So what we are going to do now is to divide each of these items, this one, this one, this one, this one. We're going to divide by this one I circle here. Divide each item by cos a cos b. Divide each item by cos a cos b. Okay, so that will be tan a plus tan b will be equal to sine a cos b all over cos a cos b, then plus this one, cos a sine b all over cos a cos b all over. Then we have here cos a cos b. So divide by itself, cos a cos b, divide by itself, cos a cos b, then minus sine a sine b all over cos a cos b. So this is what we have now. So if you check, you see that this is sine a cos a. This one will cancel out, this one will cancel out. Okay, cos a cos A will cancel out there too. This one will cancel out, that will be 1. So you're going to have sine A over cos A, which is tan A. Then plus here sine B over cos B, that will be tan B, all over this one cos A over cos B divided by cos A cos B, that's 1. Then minus tan A tan B. So that's that on tan A plus B. So that is the proving for that. Tan A plus tan B, it will be tan A plus tan B. Okay, and then 1, the sign you have here will reverse, that will be minus tan A times B. Okay, so that is that. And if this place is minus, if this is minus, let's say you have tan A minus tan B, so it's going to be the same thing also. It's going to be tan A, if this is minus, so it will be tan A minus tan B over 1 plus tan A tan B. So that's that on that. Let's take some questions to apply this. You want to pronounce it, calculate as sine 15. Okay. If you look at the information given, 45 is 45 value, we have it there in the question, and 30 value, we have it there in the question. So what we should do now is for us to think how we can use this 45 and 30 to get 15. Okay, so that will be equal to sine solution. Sine 15 will be equal to sine, use those two angles given, 45 minus 30. If you do the subtraction of those two angles given, you will have 15. Okay, can we apply our addition formulae? Let's apply all those addition formulae. Okay, and this will be equal to sine 45 cos 30, then minus cos 45 sine 30. So that's that. Let's substitute. Sine 45 is sine 45 1 over root 2 cos 30, that's 3 over 2, then minus cos 45 is 1 over root 2 then sine 30 is half. So if you do this, 1 times this, that's root 3 over 2 root 2, and 1 times 1 here, minus 1 over 2 root 2. So once these are, the denominator is the same, just subtract the numerator, that's root 3 minus 1 over 2 root 2. So that's that on that question. And before we go to the next question, I want to quickly look at those additional formula, and let's try to master that addition formulae. We discussed sine A plus B, which you say is going to be between sine, to alternating between sine and cos. So that will be sine A cos B, and then plus. Where you stop it, you start from there. That will be cos A, okay, sine B, okay. Then sine A minus B is the same thing also. Sine A cos B, and then cos A sine B, okay. For the cos of double angle A plus B, okay, it's going to be cos and sine. Cos A cos B, and then the sine here we alternate, sine A sine B. And then for the cos A minus B, it's going to be cos also, but the sine also we alternate. And that's that on that on this addition formulae, okay, which some people call it double angle. So let's go to the next question. Show that 45 plus A is equal to 1 plus tan A over 1 minus tan A. What's going to happen here? We're not going to use we're not going to do the in-depth proving. So what we're going to do is for us to apply your double angle tan A. Let me call it the addition formula plus tan B, which is equal to what? Tan A plus tan B all over 1 minus tan A tan B. Okay, so what we do now, the problem, tan 45 plus A will be equal to what? Tan, the first one, 45 plus tan, the second one, tan A, all over, then 1 minus tan 45 tan A. So that's that on that. Then we must know that tan 45 is 1. We've done that of the trig ratio of 45, 30 and 60. So tan 45 is 1 minus tan A all over 1, 1, we have plus here, 1 plus tan A, then 1 minus tan 45 is 1. So 1 times tan A, that's tan A. So that one is proved. We've proved that. That's that we can do here. This is simple. What we have to do is for us to use the table, the formula we have. Sine x plus y is sine x sine y. Okay, then plus sine. You start from here. Where you stop here? Sine x. Sorry. Sine x plus y is sine x cos y. Sine x plus y is sine x cos y. Then plus, where you stop here, cos of the other function, cos x, and then sine what? Sine y. Okay, so that's that. Sine x cos y, then plus cos x sine y. So that is just that. So, and you can see that each of them, this is sine x sine y. This is cos x, and this is cos y. This is cos x. So each of them must take those functions. I mean, sine will take x, y. I mean, cos also will also take that function also. Okay. Then let's take the other one. Sine x minus y. It's the same thing. Sine x cos y minus cos x sine y. Can we multiply the two together? Because this is multiplication that join it together. So therefore, sine x plus y sine x minus y is equal to the product sine x cos y plus cos x sine y into brackets sine x cos y minus cos x sine y. Okay, you see that what you have here and what you have here, they're the same thing. Just that you're having alternating sign. This is plus, this is minus. You're having alternating sign. Okay, just like you have a minus b or a plus b into bracket a minus b. It's a difference of 2 squared. You have the same expression or opposing sign. So this will be equal to what? A squared. The first one is squared, then minus b squared. So I'm going to apply that. And that will be equal to the first one squared. That will be equal to sine x cos y all squared. That's my a squared. Then followed by minus b squared. That's cos x sine y. Let's get it also. So, and that will give me sine square x cos square y. And this one will also give me minus cos square x sine square y. So what we are going to do now, if you look at the final illustration, final proving, show that, I didn't even finish the question, show that this is equal to, show that this times this is equal to sine squared x minus sine squared y. So that's what we are told to do. Show that this sine of this function times sine of this function is equal to sine squared x minus sine squared y. So that's the question. Okay. So what we do now, if you see the question, you realize that they are all in sine. Okay. But this expression, we're having cos there, we're having cos there. So we're going to use this from here, cos square x plus sine square x equal to 1. So this one is going to be sine square x into brackets cos square. Make cos here the subject. So that equal to, if you make cos here the subject, you have 1 minus sine square y. And then minus. Here also, cos is what? 1 minus sine square y into bracket sine square y. So what we are doing in this place is that we want to make the whole expression in form of sine, because our target there is all sine. Okay, so there shouldn't be cos there. So if you see cos, you change it to sine, and you can do that by using this identity. And begin to make cos the subject. So this will be 1 minus sine squared y. This one also 1 minus 1 sine squared. This is x function. So that's x function. That will be equal to what? That's 1 minus sine squared x. Okay. Then the next thing to do now is for us to expand this one times this one. That's sine squared x, and this one times this one minus sine squared x sine squared y. Okay, this one times 1 and then times minus, that's minus sine squared y. Okay, minus times minus plus, and this one times this one sine squared x sine squared y. Okay, which is minus here, negative here, plus here. So that one cancel out, and we're able to show that sine squared x minus sine squared y. So that one is shown. We prove it. Proved. We have proved it. Proved. Okay. I will just quickly recap what we said in a few minutes. This is a problem. Show that this 2 is equal to this. So the first thing you do, begin to state what sine x plus y is, what sine x minus y is, and then multiply them together. And the moment of multiplication, you realize that they are difference of 2 squared. Apply that. Once you apply that, you're going to have this. Once you apply this, then you look at it. Okay, this is a combination of sine and cos. But in my question is combination of all sine. So what we are going to do is for us to change wherever we have cos into sine, which we have done by using this identity. Okay, and then expand. When you expand, you get what we are told to do. Okay, you get what we are told to do. Please, if you are new on the channel, okay, please subscribe to the channel so that as we upload, you get notifications. And please invite your friend also to do likewise. Okay, if you have questions, just drop it on the comment section and we will respond to it as fast as possible. Thank you.